Melt heights. Adult melt height x follows approximately a normal distribution with a mean of 69 inches and a standard deviation of 2.8 inches. What proportion of males are less than 65 inches tall? In other words, what is the probability that x is less than 65? With a normal distribution problem, the first thing we need to do is to draw the graph, the bell-shaped curve. From the peak look down, that is the mean, and the mean is given 69. We label the mean 69 and the standard deviation of 2.8. In part A, the value x that we are interested in is 65, and so we would locate 65 on the horizontal axis here in relation to the mean 69. 65 is less than 69, so we would locate it on the left of 69, anywhere on the left accordingly, and we label this as 65. Then we're looking for the probability or the proportion that is less than 65, and so we will shade everything on the left hand side of 65. Don't forget to draw the vertical line. Once we do this, we can use a calculator to compute this probability. There are many calculators that can compute this probability. We will use Desmos normal calculator. In this case, to find the probability, we use normal dis with the mean, comma, the standard deviation by default. The standard normal distribution is given with the mean of 0 and the standard deviations of 1. But in this case, our mean is 69 and the standard deviation of 2.8, and so we would need to change that. The mean 69 and the standard deviation is 2.8, and so we would need to specify the mean and the standard deviation of the normal distribution. Next, we would need to specify the left endpoint and the right endpoint of the shaded region. This is why we should always draw the bell-shaped curve and shade the appropriate region. We're looking for p of x less than 65, and we shade it. The left endpoint, there is none. If there's no left endpoint, we would use negative infinity. If we cannot find the infinity symbol, we can use 9999 for infinity. In this case, it is negative all the way on the left, negative infinity, and so we would type negative 9999. And again, if we can find the infinity symbol, we would use negative infinity for the leftmost endpoint, since there is no left endpoint here. And the shaded region indicate that the right endpoint is 65. There we have it. The probability is 0.0766 rounded to 4 decimal places. P of x less than 65 is 0.0766. Next, what is the proportion of males are more than 75 inches tall? The same thing, we would draw the normal curve, label the mean 69, the standard deviations of 2.8. The desired x value in this part is 65, and 65 is on the right hand side of the mean 69. So we would draw the vertical line, label 65. We want the proportion that is more than, so we will shade everything on the right hand side of 75. Armed with the graph and the shaded region, we use Desmos normal calculator, and again, we would need to state or specify the mean and the standard deviation separated by a comma. 69, the mean, comma, the standard deviation is 2.8. With the shaded region, we see that the left endpoint minimum is 75, and since there is no right endpoint, we use infinity, positive. But if we don't want to find the infinity symbol, we can use 9999. So there it is. The probability is 0.0766 0.0161. And so the answer is P of x greater than 75 equals 0.0161. Now, since we're allowed to use a calculator, make sure we draw a picture, label, and say the appropriate reason. That is how we show our work. Next, what proportion of males are between 66 and 75 inches tall? Again, always draw the graph, the bell-shaped curve for normal, label the mean 69, the standard deviation of 2.8. The two desired x values are 66 and 72. 66 is on the left-hand side of the mean, so we would draw the vertical line somewhere on the left-hand side of 69. 72 is on the right-hand side, and label 72 when we draw the vertical line. Between, so we would shade everything in the middle. We're looking for the area of this region, and so again, the probability of 66 less than x less than 72 can be computed using the calculator. Open Desmos normal calculator, specifically with normal distribution feature because we're looking for the probability. The mean is 69, comma, the standard deviation is 2.8, and with the shaded region, we see that the minimum is 66, the left endpoint, and the maximum 72, the right endpoint. And there it is. The probability rounded to 4 decimal places, 0.7160. Next, how tall must a male be in order to be among the shortest 0.5% of male? 0.5% is 0.5 over 100, which is 0.005 in terms of the probability. Same thing, we would draw the normal bell-shaped curve, label the mean 69, the standard deviation 2.8. This time there is no x value. We're looking for the height, which is the x value, but we're given the probability, the area, the proportion. And this is the shortest on the horizontal line. The height should be from the shortest to the tallest. And so the shortest 0.5% should be on the left hand side. This is a proportion or the 0.005 or 0.5%. We're looking for this corresponding x values here. Open the Desmos normal calculator. This time we are not looking for the probability, but we are looking for an inverse. With the second feature of this calculator, inverse SECDF normal this, we would need to specify the mean, the same mean 69, and the standard deviation 2.8. Don't forget the comma in between. This time there's a third input here, and this input is the area in the left hand side of the corresponding x value that we're looking for. It has to be the area on the left hand side, and we see from the graph or the diagram that the area is 0.005, and there it is. The corresponding x values is 61.79 rounded to 2 decimal places, 6179, and so x equals 61.79. That is how tall a male must be in order to be among the shortest 0.5% of male. The unit is in inches. And lastly, how tall must a male be in order to be among the tallest 0.25% of males? And again, to show your work with a normal distribution, we have to draw the normal curve, label the mean 69, the standard deviation 2.8. We're not looking for the probability here. We're looking for the x values that will give us the tallest 0.25% of male. And so we're looking for the x value, the tallest, and so it is on the right hand side. And that area is 0.0025. 0.25% is not 0.25 but 0.0025. With this, we're ready to use the calculator. Open Desmos normal calculator, and again, this is not the probability that we're looking for. We're looking for the inverse. The mean is 69, comma, the standard deviation is 2.8. This time, the area on the left is not 0.0025, but it is the area on the left hand side of this x values. Recall that the total area under the curve is 1, so the area on the left hand side had to be 1 minus 0.0025 or 0.9975. And so what we need to type in this calculator is, again, not 0.95, not 0.0025, but 0.9975. And so the answer is 76.86 rounded to 2 decimal places. How tall must a male be in order to be the tallest 0.25%? 76.86 inches.